AI happens pretty fast. If you don't stop and look around once in a while, it might just pass you by.
Hello, and welcome to The Reasoning Show. I'm your host, Brian Gracely, and today I've got reason to dig into something that we kind of talk about at the fringe, but don't really dive into, and that is we spend a lot of our time talking about model providers and evolutions of coding assistants and agents and all the things that, technology people tend to dig into and touch and feel in terms of software and building software projects and so forth. But I think the reality is we all know that as these giant numbers are coming out, as forecasts are growing in terms of capacity, demand that people have, we're hearing a lot about data centers, we're hearing a lot about energy, and we really just don't spend enough time kind of understanding how that part of the market works. And while many of you may not care anything about that because you say, well, as long as my computer works and when I send in a prompt or I'm dealing with a CLI, it works, I don't care. I think it is important to sort of understand what are the challenges that are going on with that space, whether it is in finding locations for data centers, whether it is being able to satisfy demand for energy, being able to cool these both existing data centers and new greenfield data centers. And we're going to dig into all that today, right after the break. Today's show is sponsored by ShareGate. You're out of time. Copilot needs to be deployed ASAP, but your tenant really isn't ready for it. Years of data, permissions, and users lurk in its shadows, ready to be exposed by AI. ShareGate Protect sees it all, so you can find the exposure risks, fix them fast, and deploy AI with confidence. Microsoft 365 Governance, they've got this. Learn more at sharegate.com/protect. Today's show is sponsored by Nasuni. There's a growing gap in AI right now between what's possible in theory and what successfully works at scale inside an enterprise. The difference comes down to unstructured file data. Many AI initiatives struggle because the file data they depend on is scattered, unstructured, and disconnected from where and how work actually happens. Nasuni changes that. It brings your unstructured file data into a single, secure foundation so AI, both generative and agentic, can access it with the context, governance, and performance it needs in production. Bring AI to where your unstructured data lives. See what it takes to activate your data for AI and request a demo at nasuni.com/AI. And we're back. And as I mentioned at the top of the show, we are going to really dig into that intersection that we've been, kind of floating around as we talk about the market from a bigger perspective in terms of not only AI, how AI has been being used to improve things, but really the intersection of AI, data centers, and energy and power management. And really excited today to have Wani Park, who is founder and CEO of Potto AI, joining us. Wani, welcome to the show. Great to have you on.
Thanks, Brian. Appreciate it.
Yeah, we want to dive into this. We obviously spend a lot of time digging into how software is being built with AI, the LLM, sort of that entire market space around the technology stack. But, we also realize that as fast as this market is growing, there are certain constraints around it. And, some of them are things like hardware availability, but it feels like the other constraint that we don't dive into as much is really data centers being built. And one of the key aspects of that is obviously energy and power management. So excited to dig into your expertise here. Before we really dive into what Potto AI does, give us a little bit about your background, why you founded the company, the sort of space that you guys see as, a big opportunity to go improve.
Oh, yeah, absolutely. Well, thanks, Brian. So Wani Park, I am a 20-year veteran in terms of energy and power SaaS, software as a service. Done a lot of work with utilities, generation, sustainability, and all that. I think in regards to, where we are now with Potto and how we sort of came to be, I'd say about 2 years ago, we saw this opportunity where, there are these crazy forecasts, right, in terms of very volatile, peaky loads, right? And for a software guy that's trying to address those issues, these are really incredible problems or sort of a sandbox to play in. And so thought was, from a software perspective, but also in regards to, the overall ecosystem, what are things that are missing in the space? What can we do to really address it? And we had an opportunity to really partner with LG Electronics, right? So the large Korean conglomerate. And the interesting thing was, while you probably know them mainly for TVs, appliances, and things like that, they actually do a lot of work on the commercial side, right? So this is, EV batteries, BESS systems, cooling, all that good stuff. And so we had an opportunity to partner and actually take investment from them to really, build Pado and then spin it out. And so, fast forward about a year ago, we formally spun out, and then we closed our seed round about a month ago. And, with that, we also are a subsidiary now of LG Electronics. So if you sort of think about, the impact in the space, I would even go back to, I don't know, 10 years ago when like Mark Andreessen was saying, hey, software is going to eat the world and all that good stuff. The reality is in this market, that is not the case, right? Like, I think we need to be a really good citizen, have a good partnership with the hardware folks, the infrastructure folks, things like that. And that's kind of what you're seeing right now, whether it's NVIDIA skyrocketing, but also on the other side, you're seeing, folks like AMD and Intel really have their moment in the sun, but also all the infrastructure companies. So that's kind of where we are. And, really the problems that we're looking to solve is within this space, and I know we're going to probably drill into power and availability of power in a bit, but the ability to actually go a little bit deeper and understand what are all the piece parts of actually not only supporting the growth of data center development and the underlying AI, but also like who are the other stakeholders, whether it's supply chain, like you mentioned, or even the utilities or the grid operators, things like that. So I think that the team that we have, has a pretty good position on how to help, right, and help drive growth. And, that's kind of why we exist.
Oh, no, that's awesome. I want to tap it a little bit. You talked about having been around this space for quite a while now. And, you mentioned Mark Andreessen talking about software is eating the world. It feels like for maybe a decade or so, we just sort of forgot about all of the sort of physical aspects of the things we do. It was just sort of like there is unlimited computing in the sky and everything we focus upon is software. And it feels like that pendulum is swinging back to where, again, we're talking about, physical things. We're talking about chips. We're talking about data centers and capacity and power. As you're looking at not only your market opportunity, but as you're educating people, what are those big dynamics now that people need to kind of understand, the most significant? Because again, these aren't even the same data centers that we were talking about 10 years ago. So what should we be watching for? What are the are really reshaping what this new sort of data center market looks like?
Yeah, no, for sure. I mean, when I got started, right, a data center was your IT closet, right? So it's really transitioned quite a bit. But what I would say is that I don't think people understand the scale, right, of the requirements for power, for infrastructure, but also the outcomes, right? I mean, one way to look at it is when you sort of look at some of the whether it's the financials or just really the outcomes coming from folks like OpenAI and Anthropic and what they're trying to do. I would say that there's a good amount of matchmaking, right? In the sense that the demand for their services are outstripping the capacity, right? And so then you sort of have this waterfalling effect in terms of getting all the way down to the baseload power component, which is where do we get power? And so then it's also like the structure where like we're not willing to wait 3 to 4 years, right, to get interconnected to the grid. So then there's all these solutions, which then bubbles up into, hey, let's go build a data center in space, right? Like,
Sure.
It's going all over the place. And so that's actually the world that we work in. Right. But in regards to, the amount of power, and I'm sure you've seen a lot of forecasts, but I mean, people are saying like data center growth on the power side, I mean, that's going to be 10, 12% of the overall national, the load construct for North America. That's crazy, right?
Yeah.
So, how do we support that? And then the fundamental thing about that is like, you can't just flip a switch, right? There are supply chain issues, right? There are tariff issues. There's all kinds of stuff that's going on to, in essence, they could be blockers, right? But you can't just build the thing overnight, right? So many things to figure out. And so, with all those problems, I think the question then is like, how do companies come in and sort of mitigate that or bridge that until things catch up, right? And I think a lot of companies are looking to do that as well.
Yeah, no, it does feel like, the easy, I think the easy thing for people to sort of understand because it's a single company is they sort of go, okay, I know there's a need for a lot of compute or GPUs. NVIDIA sort of owns most of that market, so they can kind of look at the way that they talk about it and go, okay, I see where they've got this sort of mismatch between massive demand and them trying to supply that. I feel like it's more complicated to talk about it in your domain because there isn't sort of the NVIDIA of power, which is, just a single entity. There's a whole bunch of things, like you said, there's creative solutions about how to create your own, there's utilities, there's municipalities involved. So yeah, I'm glad we're getting a chance to sort of dive into it. You've spoken, I went back and looked at some of the things that you've talked about sort of in public and your perspective on things. You talked a little bit about, you have a perspective that you feel like right now, maybe the data centers, some of these operators are sort of running things maybe at less than peak capacity just because nobody at this point wants to be the one who has an outage, right? There's so much competition. There's so much people, it feels like there's switching costs. Do you feel like that's happening out of concern for the service themselves, or is that really more just a matter of the dynamics, the sort of physical side of things, just they're not there, in that sort of supply and demand mismatch that you talked about?
Yeah. Let me try to unpack that a little bit because, it's nuanced a little bit, right? In terms of
absolutely
how you view the market. So one thing I would say is just going back and putting on my utility hat, right? And understanding how the grid operates, right? And power is really feeding all of this, right? As the primary entry point. And hopefully this is not too boring, but, the grid is built to support the peak, right? And the peak would be, for example, let's say I'm in California, it's July, I don't know, it's July, it's super hot. Every business, every house is running air conditioning. So you build the grid to support that peak. Typically, how many times do you have to support that peak? Maybe 10 times, 12 times a year. So if you think about it, 90% of the time, right? Like we're operating at 30%. So there's a ton of capacity, right? So the first thing I would say is, how do you balance that? And maybe the best analogy, and I'll have to give it credit to Arshad Mansour from EPRI. He said this a couple times. He said, it's kind of like, hey, I need to book a hotel room, right, for the next 2 years. And then the hotel person comes back and says, you know what? I could service you 99% of the time. There are 4 weekends where you can't do it. Okay, great. I'm walking away, right? I'm going to go, generate behind the grid or behind the meter, that kind of thing. So there's that element. Now, the other side of it then is like, what is the actual infrastructure looks like? And I guess the point with the grid example is that it's underutilized for the most part, right?
Yeah.
The second piece then is that, when you actually have a data center, right, and you're talking about, underutilization of the GPUs or the power, what are the primary components, right? It's really cooling, and it's really how you're actually managing the GPU. And there's also the customer, right? And this is kind of where, is there a hard limit of utilization? And so if I were to unpack those three things, I'd say the first thing is that a lot of times with, I would say, the brownfield legacy data centers, right? They don't have super sophisticated cooling, right? It's like air blowers blowing into a room and just, basically cooling the zones almost indiscriminately, right? So what ends up happening is that like how the jobs are sort of orchestrated within the data center, it's not aligned 100% with cooling. So there's a lot of inefficiencies there. So that's one thing that actually says, hey, and this is PUE and things like that. The other side of it is that the GPU itself, because of the way they operate, are fundamentally, utilized. And I'm going to just give you sort of a high level number, but typically because of load balancing, scheduling, gain scheduling, and just sort of how the jobs are orchestrated at that level, you're probably talking about 12 to 13% utilization, right? And this is stuff that actually can be fixed or lifted, right? You're never going to get to 100%, right? You're never going to hit your nameplate, value of this stuff, but you can definitely do that with innovation. And so that's one area that we're trying to target, but that would also help. Hey, the flip side is you're just getting a better use of the power allocation that you have, right? And then the last piece really is, SLAs, right? And so within the existing data centers, they may have different, mandates of performance, but a lot of it is, the 5.9 uptime and, you can never go down and all that stuff. And there's a financial impact to that, both in terms of revenue upside for the client, but also just like, is there a clawback? Is there a penalty? Like, there's a big number there. And so, because of that, their thing is like, we have to build the peak, right? And so if a peak at some point is, 100% like the grid, we're gonna sort of dampen it down to 30, 40%, right? And so those are probably the three key factors in terms of how those businesses are run.
Oh, wow. It brings back some memories for me because I know when I was doing like network architecture for data centers, there was always there was this like you've mentioned, the sort of 5.9s mentality, which that's the thing that you want your end users to experience. But behind the scenes, you were having to figure out things like, okay, I want to have high availability, but I'd also like to sort of utilize both sides of that high availability as much as possible. So maybe you were building around 40% peak. We went through the things that we did with telco networks where you built around Mother's Day as that sort of peak. So all those things are coming back to me. I'm interested as you're seeing what's going on in the data center space, especially the AI data center space. we've seen some instances where, like, for example, Anthropic a few weeks ago or a few months ago was like, hey, if you guys do some work during these hours of the day, we'll give you access to additional tokens. Do you feel like the data center providers are trying to, I don't want to say hide that variability from them so that people can just say, hey, I just want to do work? Or do you feel like their customers are going to have to sort of be more knowledgeable about the sort of peaks and valleys so that they can get the most out of things? Where do you expect that'll sort of play itself out?
It's so funny because we're seeing a lot of that and we get it, right? And maybe, again, putting on my utility hat, I would actually compare it to, if you go back a little bit, it's sort of like within the white space of the data center, what this is really is a merging of the duck curve. If you're familiar with that concept, like when solar came and people would come home, it's a duck curve and a non-wires alternative method, right? Of how do you extend the life of the existing infrastructure without having to retrench poles and wires, T&D, that kind of thing. And so the thing about that then is like, if there's an element of duck curve and non-wires alternative within the white space, what is the outcome, right? Incentives then that come beyond that, which is really like, hey, if you push your jobs to like after 10 o'clock, we'll give you an incentive, right? If you think of it that way, then it's really no different, right? In terms of how that works. And I would just say that we actually see that in real time. And I'll just give you an example. Like, my team, we use Google Gemini, and we have a meeting, we transcribe it, we have video, and it's interesting. So like an hour meeting could be millions of inferences, right? That is being captured. And the thing is like, it's interesting because sometimes we'll get it within 10 minutes, sometimes we'll get it within 2 hours, right? And it's just sort of like arbitrary, but it's not, right? It's because there's so much demand at a certain point, and the peak is crazy. Let's defer it a bit and let's bounce it out and see if the customer gets angry, right? So we're seeing stuff in real time, and I think those are some interesting examples.
Yeah, no, I think if you've lived in certain parts of the country, like I'll use the U.S. for example, there's times when, like you said, when it's hot in the summer, where energy company will incentivize you to run your air conditioning lower, or do your laundry at certain times of the day. Again, they're trying to manage, and they're ultimately trying to manage the realities of their business with, like you said, trying to figure out like, well, how will you respond to that? Like, how angry will you get? How offset will you get? How encouraged will you be? They're managing sort of math and emotions at the same time. So it's interesting.
And Brian, maybe just to add one more layer there, and even trying to quantify it is, given specific capacity of compute or power that these data center operators have, there's a temptation, I would think, to sort of get away from the 5 nines and actually oversubscribe, right? Because oversubscription, what is that? That's just upside on revenue. As a lot of these companies go public and they have to report and they have to, continue to drive growth and things like that. But you have a bottleneck on the infrastructure side. What do we do to drive growth? And so this is one of those methods, right, to continue to drive growth. And, the amount of revenue that this compute actually throws off is versus the flexibility, it's pretty massive, right? You're talking 50x, right? So,
Yeah. And we've, as humans, we have a natural back off thing. Goes, oh, it didn't work. Just try it again. Push the retry button and so forth. I want to talk a little bit about, you guys are obviously, you're in the technology stack that is trying to optimize around this. Help me understand what does that technology stack look like that is that sort of Venn diagram between power and data center and leveraging AI, and then where does Pato AI really kind of fit into that space?
Yeah. So great. So if we were to start like trying to view the data center as simply gray space, white space, right? I would say that just Pato, and then also just like, our affiliation with LG, we have a really good, strong position on sort of bridging that, right? The gray space and the white space. And if you think about it, on the gray space side, let's just talk about cooling, like just focusing on cooling. And going back to my earlier point, which is like, there's probably a better way to be more precise about cooling. And what we try to do is take it down, and I'm going to go kind of circular, but take it down to the job level, right? So when the job, these are inference or training jobs are in the queue and, be ready to get deployed, to actually operate, how do you match those jobs up based on priority, based on timing, based on, different things like that with cooling, right? Is there a way to sort of, align that better? And right now, I think especially with legacy data centers, it's not really that. It's not right? It's just sort of shotgun. And so there's an element there where our integration, with the cooling system, right, brings in the ability to not only analyze workloads, but also, again, deploy cooling in a more effective way. So the way to think about it is that you may have a situation where within certain zones of the data center, let's just say it's zone 1, it's all inference. Zone 2 is all training, just for simplicity, right?
Yeah.
And training may have a little bit more lead time or flexibility in terms of when it needs to either start or finish, rejigger cooling based on those zones, based on jobs, right? And what that does is it allows for more reallocation of cooling to, let's say, inference, right? Versus, having to go all in or equal, right? Based on zones. So there's an element of that. And obviously, if you're talking about how does AI, from our perspective, sort of deploy, our ability to not only extract the data, make recommendations, but on a go forward to actually deploy actions, right? To automate it through agents actually helps a lot, right? So then you basically have a really good full cycle, solution in regards to cooling. So that's one way to think about it. And I would also add that, for us, at least as a company, we're more focused right now on sort of non-hyperscale greenfield, more focused on existing legacy brownfield, because I think that's where like a lot of the juice can be squeezed, right? So yeah, I'll stop there for a second. Is that?
No, it makes a ton of sense. I mean, you guys in essence live sort of between these power and cooling systems and other systems that are there, and you're really, like you said, there's so much sort of variability throughout any given day. You're really trying to smooth those out. You're trying to make those curves a little smoother, and then as dynamically as you can, reallocate resources or redirect resources. It makes a ton of sense. Obviously, there's a lot of buzz about Stargate data center or another giant data center. You talked about living in the brownfield space. Is that more kind of existing co-location type of companies, or is that like even large enterprises like banks or others who are beginning to bring GPUs into their environments?
You're talking about our target market.
Yeah,
for sure. I mean, I would say, for us, we're very focused on neocloud enterprise, and I would say sort of mid-market, right? I think that's where we're seeing a lot of that action and the appetite for doing that, And in regards to the larger greenfield, like a lot of it's very vertical, right? And, folks are building things themselves and things like that. So, all seeking the same goal, but, different in terms of how we go to market.
Yeah. And how are you? So we're seeing these evolutions of these, in some cases greenfield, in some cases sort of brownfield. What should people, if you are, let's just take an enterprise company who's looking at AI, like, should you even be paying attention to kind of what's going on with the kind of utilities space and how that's kind of evolving and what their interconnects look like? Do you just sort of go, those folks will figure that out, I don't have to worry about it. It's, as long as the GPUs fit and the building doesn't burn down? Like what as like, say, an enterprise customer, whether you're consuming from a neocloud or you're consuming from your own data center or something in between, like how aware do you feel like those folks should be of what's going on? Or, is just the nature of the market just kind of making things more efficient so people don't have to, and users don't have to think about it that much?
Yeah. Interesting. So one thing I would say is, at least let's talk about the enterprise side of things first, right? Like you're an insurance company or your bank or financial institution. One thing I would say is like a lot of their sort of internal development and the direction they're headed with AI, whether it's their existing data center or their own personally owned data center or third party, is that all of that is actually moving to the edge in the sense that it's much more customer facing, which basically then says, hey, we have to be a little bit more cognizant of what's happening around the inference infrastructure, right? And I would actually argue that the enterprise, right, are actually really well positioned to do that, because this is not one of the situations, for the most part, where, gosh, like I got to retrofit and redo my entire data center, right, and bring in the top of the line NVIDIA technology. It's actually one of those situations where, hey, we can actually extend the life of our existing infrastructure. Maybe it's a little bit of addition, right, on the GPU side, but repurposing the existing CPUs and whatever infrastructure they've got, because the power requirements aren't there, right, from a training perspective versus an inference perspective. So a lot of times, like this kind of goes back to that non-wires alternative analogy, they have the ability to do that. Now, if we agree on that, and that is the case, then the question is like, well, what can we do more to squeeze more juice out of this stone? And this is where the optimization stuff, the cooling stuff actually comes in, and you can allow them to do that. And so what ends up happening is that you get more productivity. That could be revenue or token production per square foot per hour. The second thing is then within the power envelope, right? Like, it can defer any CapEx. And the third thing then is that if you do have excess power, right, because you're optimizing some of this more effectively, you can basically sell back some of that flexibility, especially since you're in essence an inference data center. And then within the grid, the local community, a lot of utilities are trying to create programs and incentives to provide flexibility. And this is a way to do it, right? Without really, affecting your business. Much more aligned with the enterprise, I would say, because, their business is not, selling third-party compute. So
Right. Yeah, it's not power generation, it's pharmaceuticals or whatever it might be. Yeah.
That's right.
No, we kind of hit on this idea that these companies, the data center providers and so forth, are sort of having to not make a trade-off, but they're trying to find a balance between running a business, trying to be profitable in business, be efficient, and then kind of having to balance the customer experience type of thing. The other thing that they're having to balance very much is this idea of sustainability and reliability, and then profitability, and there's trade-offs in each one of those things. What do you see is the market right now, because it's moving so quickly and so forth? Are one or any of those kind of everything sort of falling into profitability, or does sustainability kind of just go hand in hand with profitability? Because given period of time, if you're using less water, if you're more efficient with stuff, like how do they think about it? And then, where are they getting kind of pressure, whether it's at the board level or local communities? How are those three things kind of intertwined these days?
Man, tricky question. And I think there's also like a timing element of it, right? Like, what is it today? What was it yesterday? Was it next week? But I think one way to view it is, it really depends on, like, are you planning on connecting to the grid, or are you planning on doing all of the stuff behind the meter, right? Because I think there's two very different go-to-markets or strategies, right? I think alignment with the grid does bring a lot more access to sustainable solutions or renewables and things like that. And it also aligns with, like, maybe potentially, things with like batteries and stuff like that. And, like even like generation from solar farms and things like that. So there's an element there where I think it's a little bit more manageable and reliable. Now, if you're going, behind the meter and sort of building your thing out yourself, and you're talking about like a massive data center, I mean, it's its own grid, right? And the thing about that, which I think is interesting, is that if you're going to make that level of investment, you're literally building your own grid. And so you're not going to revert back to the grid in 5 years, probably not 10 years, probably never, right? And so there's an element there where, like, okay, we have to be self-sustaining. They'll probably invest more in, battery storage and things like that. But I would also argue that they're probably going to invest more on, maybe, on the natural gas side and, less renewable type resources. And so there's a cycle there. And maybe at some point, they reduce the reliance on that stuff. But I mean, again, these are big numbers, right? And so I think that's an issue, right? And so there's probably a bifurcation of, like, the emphasis on sustainability. But, you're also seeing folks that are actually really contracting through PPAs or other programs like that to kind of say, hey, we get a massive allocation, from solar. I think Google and Meta have announced a few of those. And, there's an element there where, coupled with batteries, you can probably create a pretty sustainable solution, right? And maintain the reliability and things like that. But it's tricky. And, like, there's a lot of, backlash or folks from the community. I mean, I know in recent days, there's been a little bit of back and forth in Maine, right, in terms of, the new data center development moratorium and all that stuff. So, like, there's a lot of that happening, right? And I think, got to figure out how to deal with that as well.
Right. Yeah, no, by no means, like I said, it's by no means a kind of cut and dry thing. It really is, a little bit, you sort of like a balloon, you squeeze a little bit here, you're having to make some trade-offs or find some other leverages in other places. So I want to wrap up with sort of one question, and this really kind of about what you guys do. What is the technology discussion that you guys are having on a day in and day out basis, as far as where your role is, where you provide efficiencies, what people are looking for, like what they're pushing you to help them achieve? Like, what is that broader conversation that you have? Is it mostly focused around power efficiencies, around cooling and inputs, or is there a different conversation that's also happening at the same time?
Yeah. No, thank you. Very specifically, what we do is we get down to the workload side of things. So just think of it as a data center. You have all these jobs that go into the queue. There's usually like a scheduler or something like that. We take all those jobs, we profile it, we align it with the business goals of the data center or the tenant, and then we basically forecast, right? So if you think about it, like even just from an energy perspective, instead of forecasting demand on power, what we do is forecast demand on compute, right? And then the idea then is like, if you take a three-dimensional view, which is power allocation, cooling, things like that, GPU utilization, SLAs, we take sort of that 3 to 5 degree sort of view on, the business goals of the company, and then optimize it to basically, maximize compute per megawatt. Like that's what we do. And I think that, from a brownfield perspective, that's very, very, very attractive, right? Because we can test it, digitally through our digital twin. We could simulate it before, you go all in, and the ability to actually say, we could squeeze more returns out of your current investment and your power allocation. I mean, it's a win-win, right? Like that's the way that we're actually articulating it. And the feedback's been really fantastic. So,
yeah. You may not have this. I know, the company's only a couple of years old. Like, are there some metrics that you're able to now sort of highlight for people in terms of either percentage cost savings or extending the life of GPUs or, things that are sort of common that people can then, again, build their models around?
Yeah. No, I think it's a good question. So what I would say is, if I would just tackle two like specific buckets on the cooling side. So, I was talking about some of the cooling optimization, we can probably squeeze 20% cost savings, right? By reallocating cooling. And the way to look at it is like, if you're looking at a standard baseline output of compute, right? We could basically let you hit that number, 20% less energy. We don't look at it that way. We actually reallocate the 20% to actually increase compute and revenue. But again, depends on the SLA. I think that's one piece. Now, the second piece of it is, I was talking about sort of like the underutilization of GPUs. The way we do it on terms of the scheduling and forecasting piece, which I just talked about, we actually, again, it's pretty underutilized, but we can probably juice the utilization through scheduling by about 60%. And so that doesn't, and just clear, that doesn't mean, hey, all in, because there's so much leakage, but at certain phases, we can actually increase compute. And that's a significant dollar amount, right? Which I don't have right now, but it's a significant dollar amount in terms of, some value from that sort of brownfield data center perspective of squeezing more returns out of their investment. I don't really have a metric on, extending life and things like that. That's sort of beyond our control. But the idea is, depending on, how they maintain their infrastructure, this should be a good adder.
Yeah, no, absolutely. Yeah, I asked because again, since these things are new, you're always looking for sort of what are the 2 or 3 things that segment of the market is just always sort of talking about or measuring themselves. So I appreciate the framing that you have. It gives us some things to take a look at. Well, listen, I want to wrap it up there. I know you're a busy man. You're running a fast growing startup. Thank you for the time today. Folks, I want to thank Wani for his insights into this. And again, we'll put some links in the show notes so you can follow up with him if you are in this space. You are trying to make your data centers more efficient. You are looking for data center providers that are able to give you more bang for your buck and so forth. So I want to thank you again for that. Folks, thanks for listening to the show today. Thanks for telling a friend about the Reasoning Show, helping us grow the community. And with that, we're going to wrap it up and we'll talk to you next week.
Check us out online at reasoning.show for all things reasoning. And leave a 5-star review wherever you listen to the show.